Good morning students, this is Latif sir. Today I am going to discuss about periodic properties and variation in periodic properties. So first you have to know what is periodicity and cause of periodicity. You have already studied in class 10 about periodic properties and periodicity. So what is periodicity? Periodicity is the repetition of similar properties after regular interval is called periodicity. The repetition of similar properties after regular interval is called periodicity, and the cause of periodicity is the similar electronic configuration of elements. The cause of periodicity, that is the properties of element, are the repetition of similar electronic configuration of element as the atomic number increases. So the cause of periodicity is the similar electronic configuration of element as the atomic number increases. Now periodic properties. You have already studied in class 10 what are the periodic properties. The properties of elements which are directly or indirectly related to their electronic configuration. The properties of elements which are directly or indirectly related to their electronic configuration and so a regular gradation as we move across a period, that is from left to right, or down the groove, that is from top to bottom, are called periodic properties. And some important periodic properties are atomic radius, ionic radius, ionization enthalpy, electronegativity, electron affinity, metallic property, non-metallic property, that metallic character, non-metallic character, reduction, oxidation reduction character, that is oxidation property, reduction property, and valency. Valency. These are some important periodic properties. You have to know about these periodic properties and variation of these periodic properties. So first periodic property is atomic radius. So what is atomic radius? The distance from the center of the nucleus to the outermost cell, that is to the valence shell of the electrons in the atom of any element, is called its atomic radius. The distance from the center of the nucleus to the outermost shell of the electrons in the atom of any element is called its atomic radius. And what is the variation in atomic radius? Variation in atomic radius in period, that is along any period, atomic radius of element decreases from left to right in a period. Atomic radius of element decreases from left to right, and in group atomic radius of elements increases on moving top to bottom in a groove. On moving top to bottom in a groove, atomic radius increases from top to, on moving from top to bottom. Next, ionic radius. It is similar to atomic radius, but the term ionic radius is applicable for ions. So the effective distance from the center of nucleus of an ion up to which it has an influence on its electron cloud is called its ionic radius. The effective distance from the center of the nucleus of an ion up to which it has an influence on its electron cloud is called its ionic radius. And variation is in ionic radius is similar to variation in atomic radius, that is in a period atomic ionic radius also ionic radius of elements also decreases from left to right, and in group at ionic radius of element increases on moving from top to bottom. Next periodic property is ionization enthalpy. What is the ionization enthalpy? Enthalpy means energy. It is also called ionization energy, and it is represented by delta H or IE, delta IE. Okay. So ionization enthalpy. What is ionization enthalpy? The ionization enthalpy is the molar enthalpy change or energy change accompanying the removal of an electron from a gaseous phase atom or ion in its ground state. That means, in simple word, the energy required to remove an electron from the valence shell of an isolated gaseous atom. The energy required to remove an electron from the valence shell of an isolated gaseous atom. And the enthalpy change for this for the reaction, the reaction given here, you can see m is a element in gaseous state. So m within first bracket g arrow m plus within first bracket g plus 1 electron. So after removing 1 electron, m becomes m plus, the element becomes cation, monovalent cation. So energy required to remove 1 electron from m is known as ionization energy or ionization enthalpy of the element m, and it is represented by delta H1, the first ionization enthalpy of m. And you can remove more than 1 electron, and the energy required for the subsequent uh, successive ionizations are represented by or are called, are also termed as second ionization enthalpy, which is written as delta H2, third ionization enthalpy, which is represented by delta H3, etc. So the term ionization enthalpy is taken from the for the first ionization enthalpy delta H1 and is expressed in kg per mole or electron volt unit. So an element can have more than one ionization enthalpy. Okay, that is first ionization enthalpy, second ionization enthalpy, third ionization enthalpy. Now variation in ionization enthalpy or ionization energy. Generally, ionization energy or ionization enthalpies follow the order, although there are few exceptions, and the general order is delta H1 is less than delta H2 is less than delta H3. So that means the first ionization energy or first ionization enthalpy of an element is less than second ionization enthalpy, which is less than third ionization enthalpy. And the ionization enthalpy decreases on moving from top to bottom in a group. Ionization enthalpy decreases on moving from top to bottom in a group, and the ionization enthalpy increases on moving from left to right in a period. This is the variation in ionization enthalpy. Okay, so next day I'll discuss about the factors affecting ionization enthalpy and the others about others periodic properties. Okay, thank you, students.